The topic for discussion is electrolysis. I want to look at the various important electrolytic concepts such as electrolysis, electrolyte, non-electrolyte, electrodes, and conductor. First, electrolysis. I have three definitions of electrolysis. Definition number one: electrolysis is the chemical decomposition of a compound, either in molten or solution stage, by the passage of electric current. Definition number two: electrolysis is the passage of electric current through molten or solution of the electrolyte with decomposition at the electrode. For the definition number one and definition number two, it is important for students to mention molten or solution of the compound, because compound only conduct in aqueous solution where their bonded ions dissociate into free mobile ions, which are responsible for conduction of current. Definition number three: electrolysis is the conversion of electrical energy to chemical energy. I want to look at another concept of electrolysis, that is electrolytes. Electrolytes are substances that conduct current either in molten or solution state with decomposition at the electrode. It is important to note that in solid state, electrolyte does not conduct current because their ions are bonded together and are not free. However, in aqueous solution or molten state, the bonded ions dissociate to give free ions, which are responsible for the conduction of current. I want to look at examples of electrolytes. Examples are salt, such as sodium chloride, potassium chloride, copper 2 tetraoxosulfate sea salt, etc. Another example is alkali, such as sodium hydroxide and potassium hydroxide. Another example is strong mineral acid, such as hydrochloric acid, triazonitrate 5 acid, and tetraoxosulfate 6 acid. Another example is weak mineral acid, such as triazocarbonate 4 acid, triazosulfate 4 acid, diazonitrate 3 acid. The last example is organic acid, such as ethanoic acid. I want to look at the types of electrolytes. There are two types of electrolytes. These are strong electrolytes and weak electrolytes. Strong electrolytes are substances that dissociate or ionize completely in aqueous solution to give large amount of ions. Because the solution of strong electrolyte contains large amount of ions, they have high molar conductivities. Examples of strong electrolyte are salt, such as KCl, NaCl, CuSO4, etc. Examples of alkali are sodium hydroxide and potassium hydroxide, while other example is strong mineral acid, such as HCl, HNO3, and H2SO4. Weak electrolytes. These are substances that dissociate or ionize partially in aqueous solution to give few ions. Because the solution of weak electrolytes contains few ions, they have low molar conductivity. Examples of weak electrolytes are weak mineral acid, such as H2CO3, HNO2, H2SO3, etc. Other example is organic acid, such as ethanoic acid. I want to look at another concept, that is non-electrolytes. Non-electrolytes are substances that does not conduct current, either in solution or in molten state. They consist of molecules and not ions, hence they do not conduct current. Examples of non-electrolytes are 1. Tetrachloromethane, 2. Benzene, 3. Petrol, 4. Kerosene, 5. Sugarcane, etc. I want to look at another concept, that is electrodes. Electrodes are metal rods or graphite rod through which conventional current and electrons enters and leaves the solution of the electrolyte. The common electrodes that are used in electrolysis are graphite rod and platinum rod. and this is because they are inert and they do not take part in electrolytic reaction. I want to look at the types of electrode. These are anode and cathode. It is important to note that in electrolysis, conventional current flows in opposite direction of the electron, while in electrochemical cell, current flows in the same direction as electron. The anode. Anode is the positive electrode through which electrons leave the solution of the electrolyte, and conventional current enters the solution of the electrolyte. The anode is the site of oxidation reaction. That is, oxidation reaction occurs at the anode. It is important to know that in any electrolytic cell, anode is always on the left side and is the electrode that is connected to the positive terminal of the battery cell. The positive terminal of the battery cell is represented by a long stroke. Now the cathode. Cathode is the negative electrode through which electrons enters the solution of the electrolyte, and conventional current leaves the solution of the electrolyte. Cathode is the site of reduction reaction. That is, gain of electron occur at the cathode. The cathode gains electron from the anode and loses the electron to the cations in solution. It is important to know that in an electrochemical cell, the cathode is always on the right side, and it is the electrode that is connected to the negative terminal of the battery cell. The negative terminal of the battery cell is represented by a strong stroke, by a short stroke. Conductor, which is the last concept I'm looking at. Conductors are solid metal rods that allow current to pass through and are not decomposed by the current. In conductor, it is the mobile or free electrons that conduct current. I want to look at the differences between conductor and electrolyte. Examples of conductor are metals such as sodium, potassium, magnesium, etc. While examples of electrolytes are potassium chloride, sodium chloride, copper 2 tetrahydrosulfate, sea salt, etc. Now the first difference. Conductors are always in solid state, while electrolytes are either in solution or molten state. Point number 2. Conductors are not decomposed by current, while electrolytes are decomposed by current at the electrode. The last point. In conductor, it is the mobile electron that conducts current, while in electrolyte, it is the mobile ions in solution that conduct current. Thank you.